Welcome to Kindergarten Video on Demand. This video is an overview of Unit 5A, Patterning and Number Relationships. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 5A. Chapter 1, AKS and IOAs. In this portion of the video, we will review the AKS and the Indicators of Achievement, or IOAs, for Unit 5A. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in the unit are paced in detail. This unit has 3 AKS. Under the AKS, you will find the Indicators of Achievements, or IOAs. You will also see that we have provided you with the state coding at the end of the IOAs so that if you are looking up resources on the Georgia Department of Education website, you are able to find the state IOA that is related to the GCPS IOA. The heart of Unit 5A is work with AKS 5, specifically IOA 5A. AKS 5 addresses students explaining the concepts of addition, subtraction, and equality to solve real-life problems within 10. Our overall goal of AKS 5 is for our students to add and subtract with the different problem types, but we're not there quite yet. Unit 5A focuses on the relationship between a whole number and its parts. Unit 5A includes IOA 5A, compose or put together, and decompose or break apart numbers up to 10 using objects and drawings. With this IOA, we either know the whole and decompose it into parts with part, whole, both parts unknown problem types, or we know the parts and need to compose them to make the whole with part, whole, whole unknown problem types. At this point, we are not introducing students to the terms addition and subtraction or equations using the addition and subtraction symbols. Instead, we use sentence stems such as blank is the same as blank and blank, or blank and blank is the same as blank. The goal of IOA 5A is to provide opportunities for students to develop an understanding of part-whole relationships. They will then use this understanding to solve joining and separating problems with the result unknown in Unit 5B of kindergarten. Students will continue to use this understanding of part-whole relationships in first grade to solve change unknown and start unknown problems, and even in later years when they solve addition and subtraction problems with fractions and decimals. AKS 6 states, explain, extend, and create repeating patterns with a repetition not exceeding 4. Describe patterns involving passage of time. The study of patterns provides opportunities for students to make connections. These connections help to build a foundational understanding of algebra as it relates to addition and subtraction strategies, the count sequence, and geometric understandings. IOA 6A states students will describe a repeating pattern with no more than 4 repetitions or iterations of the core, which is made of shapes or numbers. This can also be extended to a repeating pattern of objects. Once students have identified the repeating pattern, they extend the pattern. Students also create patterns of their own. It is important to know when showing students a pattern to describe and/or extend, the entire core should be created in the repetition. For example, if the pattern is triangle, square, square, the entire core must be shown at least twice. With IOA 6B, students should be able to describe patterns involving passage of time using words and phrases related to actual events. The final AKS in Unit 5A is AKS 2, which is one of our ongoing AKS throughout the year. AKS 2 consists of student rote counting forward to 100 by ones. Starting at 10, students will rote count forward by tens to 100. This standard requires students to rote count backwards from 20 And students will also count forward within 100 and backward within 20 from any given number. Chapter 2, Unit Pacing. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at our pacing guide for Unit 5A. Okay, so we're on our pacing guide for quarter 3, which is when we will be doing Unit 5A. So in the box which names the unit, you'll see the suggested pacing. For Unit 5A, we suggest about 3 weeks. The big ideas, numerical reasoning, and patterning and algebraic reasoning are included, as well as any links we feel would be beneficial for the entire unit. Next, you will see a list of the AKS and IOAs which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progressions for the AKS and IOAs, whether this be the concrete representational abstract progression or progression between specific learning targets within the IOAs. Suggested manipulatives are also included in this left column. The right column provides resources to guide instruction. So if we look at our pacing guide for these 3 weeks of Unit 5A, you will see our work with Unit 5A begins with 1 day on IOA 6A, describing and extending repeating patterns with shapes at the representational level. We will also introduce objects because our lesson includes not only shapes, but it includes coins, again, at the representational level. After this day, work with IOA 6A will move to the activating strategy. In the next unit, 5B, students will build on this IOA with an introduction to repeating number patterns, as well as continue repeating patterns with shapes and objects. Our work with AKS 2, rote counting, will also occur during our activating strategy. Specifically during Unit 5A, we will extend counting on from any given number within 100, and we will introduce counting by tens to 100. A slide deck for activating strategies is included, which will guide work with this AKS. So you can see here on even this first day of IOA 6A, it says slide 2, and we've given you the skill here over on the side. So when we do slide 2, it's going to focus in on rote counting. So I'm going to click on that so that you can see what these slides look like. Okay, so here they are. It's just reminding us here of all that AKS and IOAs that we will be addressing. And then, so for example, here's the one for that very first day. It's slide 2. So they're going to be rote counting backwards from 18 to 0. And then you'll see later on, we suggest slide 3. This is where they're going to be counting by tens. And these slides continue on. They are built in a progression to continue work with AKS 2, IOAs 2A and 2B, as well as our IOA 6A patterns, and even some passage of time you will see in our activating strategy slides for quarter 3. Okay, so that's what those look like. After we spend our 1 day on IOA 6A, we're going to move into about 14 days being paced for IOA 5A. Remember, this is our compose and decompose numbers within 10. So about 11 days are spent at the concrete level, allowing students to gain conceptual understanding of that part-whole relationship. Students will begin with decomposing a whole into its parts, and they'll do this in multiple ways. First, with numbers within 5, so 5 and less, and then we'll move into numbers, here we go, within 10. So we want to start off small with those numbers within 5, and then we'll move into numbers within 10. The bullets on the left side of the pacing guide state whether the focus of the learning is on decomposing or composing, as well as the size of the number. So we saw that up here when we first began, where we are decomposing 5 into parts. numbers less than 5, 10 into parts, and then our numbers 6 through 9. So we do that progression, really wanting to create 5 and 10 as anchors because we know how important those are in mathematics. You may notice the sentence stems with the addition and the equal sign are not included. This is intentional as symbols will be introduced in the next unit when we discuss what it means to add and subtract. Please note, students will be introduced to the symbols and equations in Unit 5B, but mastery of equations and symbols is not a kindergarten expectation. So during Unit 5A, we're going to use those sentence stems. Excuse me. So for decomposing, we will use blank. So whatever the number is the same as its 2 parts. And then as we move on down and we get into our composing, our sentence stem will flip and we'll have our 2 parts. Blank and blank is the same as, and then that whole. After gaining an understanding of what it means to decompose a whole into parts, we will move into composing parts to make a whole. After work with both decomposing and composing at the concrete level, we will spend approximately 3 days at the representational level in which it is a mix of decomposing wholes and composing parts. Work with this IOA will be put into a real-world context. This is intentional as it helps students to build conceptual understanding of what it means to be a whole in parts and how this relates to everyday life. And after those 3 days at the representational level, we will be at the end of Unit 5A. So 5A focuses on IOA 5A, and it is paced for approximately 3 weeks. Chapter 3, Instructional Strategies. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Now let's take a look at possible instructional strategies in action. This video, we're going to look at IOA 6A, create, extend, and describe repeating patterns with numbers and shapes and explain the rationale for the pattern. And during Unit 5A, we're going to be working at the representational level, specifically with shapes and objects patterns that are repeating. So here's a sample of what this might look like with students and the instructional strategy that we may use. So if I look at this problem, Aria looks at the pattern. She says if she extends the pattern, she should put a circle next. Do you agree or disagree? Justify your thinking. So if I'm thinking through what a student is going to need to do with this pattern, one, it's wanting them to analyze someone else's work, right? We need to find out if that is correct or not, that the circle should come next. And in order for a student to be able to do that, they're going to have to know what is the pattern, what is the core that is repeating. And once that core has been identified, would the next shape that we put to extend it be a circle? So we want to start back all the way at the beginning with identifying the core of this pattern. And so what we might show our students is that to do this, I just want to start off by saying, what do I see? Well, I notice I see a triangle, triangle, circle, triangle, triangle, circle, triangle, triangle, circle. And I'm noticing that it begins with triangle. It looks like it has 2. And then there's a circle. And then I see triangles again. So I'm wondering if that might be where it starts to repeat. So I'm going to go ahead and underline the triangle, triangle, circle. If that repeats, then I know that's my core. So triangle, triangle, circle, does that repeat? Triangle, triangle, circle, it does repeat. Let's see, does it repeat again? Triangle, triangle, circle. So the core of my pattern, or how I could describe this pattern, is it's made up of a triangle, triangle, circle. And I can see that core, triangle, triangle, circle, has been repeated 2 more times. So I have it a total of 3 times. So triangle, triangle, circle, there it is, 1 iteration of it. Here it is again. And here it is again. So I know when I have patterns, I have a core and it repeats. So there it is, it repeats, it repeats. If I wanted to extend this pattern, I would want to repeat the core again. And I know when I repeat a core, I have to repeat the whole core starting at the very beginning. So I would want to repeat with a triangle, triangle, and a circle. So I would have that whole core repeating for me to extend it. So triangle, triangle, circle, triangle, triangle, circle, triangle, triangle, circle. I need the core to repeat. I'd have a triangle, and a circle. So now that I know what the pattern is, what's the core, so I can describe it, I've even thought how I could extend it. Now I can look back at this question and it says, if she extends, should she put a circle next? So that means if she were to extend it in this spot right here, she would put a circle. And I disagree with that because I need to repeat from the very beginning of the core, and the triangle is what the pattern starts with. So Aria should put a triangle because her core starts with a triangle. She should not put a circle. So again, this is the work that we're going to be doing with patterns at the representational level when we describe them and extend them. So same thing we've been doing all year, but now instead of having the concrete materials in front of us to touch these patterns, we're going to be looking at pictures of them. In Unit 5A, we're going to be working with IOA 5A, compose and decompose numbers up to 10 using objects and drawings. So we're going to start our work with Unit 5A, decomposing numbers to whole numbers to find their parts. And of course, we're going to begin at the concrete level. So decomposing numbers at the concrete level could look like this. So here's our problem. Andre goes to the park. He sees 8 animals. Some of them are dogs and some of them are ducks. How many of each animal could Andre have seen if he saw 8 animals? So we want to start off by, of course, thinking through the problem with our students. So what do we know about this problem? We know he went to the park. We know he saw these animals. And when he saw animals, some of them were dogs and some of them were ducks, or a part of the animals were dogs and a part of the animal were ducks. And what I'm trying to figure out is how many could he have seen of those 8 animals that were dogs and how many could have been ducks. So to kind of help us organize our thinking, we can use a part-whole organizer. So if we go back to the problem, we know we saw 8 animals. A part of those animals were dogs, and a part of those animals were ducks. So if I think about the part-whole relationship, I have a part that are dogs, I have a part that are ducks, and when I put those parts together, that's what made the animals that he saw. I do like to label my part whole just because it helps to keep it in context with what's happening in the problem. So if I think about what do I know from my problem, I know he saw 8 animals. So I can go ahead and label this with the number 8. Do I know how many dogs he saw? It just says some. Do I know how many ducks he saw? No, it just says some. And I'm trying to figure out if there were 8 animals, how many could have been dogs and how many could have been ducks. So this is where now that we've kind of thought through what's happening in the problem and we've got it organized, now we can actually pull out the manipulatives. Well, I know he saw 8 animals. So because he saw 8 animals, I'm going to get 8 color tiles. 3, 4, 5, 6, 7, 8. I want to make sure I have all 8 there. So here are my 8 animals. Some of them were dogs and some of them were ducks. So let me think through what this could have been, because I don't know. Well, if I take one of my animals and I say it's a dog, and only one of them is going to be a dog, then that means all these other animals have to be ducks. So 8 animals could be 1 dog, and then 1, 2, 3, 4, 5, 6, 7 ducks. So 8 animals is the same as 1 dog, and 7 ducks. And I could record this using my sentence stem. We actually have one at the bottom of the part whole organizer, or you may choose to have them separate. So let me think about, what did we start with? We started with our whole 8. So 8 animals, here I am, I'm just going to record it, is the same as 1 dog and 7 ducks. At the concrete level, you might decide just to do it at the concrete level and not try to record it, but possibly just say it. Well, that's one way he could have seen 8 animals, but what's another way he could have seen 8 animals? What if one of these was actually a dog? So now there are 2 dogs. If he saw 8 animals and 2 of those were dogs, how many would have been ducks? Well, let's see. 1, 2, 3, 4, 5, 6. So 8 animals is the same as 2 dogs and 6 ducks. So I could record that as a possible combination to make that whole group of 8 animals. 8 is the same as 2 dogs and 6 ducks. If you want, you could, of course, okay, we have all 8 animals. We already tried 1 dog. We tried 2 dogs. What if Andre saw 3 dogs? Just 1 more dog. So he saw 3 dogs. Then the rest of these animals would have to be ducks. So I'm going to put them all over here. So 8 is the same as 3 dogs and 1, 2, 3, 4, 5 ducks. So 8 is the same as 3 and 5. So you would continue to go through this, making the different combinations for the number 8. So if we have 8 as our whole, what could possibly be our 2 parts? So this is what this work might look like at the concrete level, using a part whole organizer just to organize your thinking. With IOA 5A, we will also compose or put together parts to make a whole number up to 10. And we'll use objects at the concrete level as well as drawings at the representational level. So what might this look like? So here's a problem. Trey went to school supply shopping. He got 2 red notebooks and 3 blue notebooks. How many notebooks does Trey have? So before I try to create models, I want to think about what's happening in the problem and what do I know. So I know that there's a boy and he went shopping and he bought some red notebooks and then he also bought some blue notebooks. And I want to put all those notebooks together to see how many notebooks he has. So if I think about what I know and I want to organize my thinking on a part whole organizer, I know he's got notebooks. Part of them are red, so I can just label a part red. Part of them are blue. And all together, this makes his school supply of all of his notebooks. So I have a part that's red, a part that's blue, because I have red notebooks and blue notebooks, but together they're just plain notebooks. Okay, so now I'm ready to go back to the problem and see, what do I know? Do I know how many notebooks there are? Do I know how many are red? Do I know how many are blue? And then create that model. So if I think about what the problem tells me, he got 2 red notebooks. So if I want to, I can write the number 2 in here, but I'm also going to represent it with my 2 red color tiles. So here they are. And of course, you can use any manipulative that you would like to use. And then it also tells me he has 3 blue notebooks. So that's another part. I have 3. So I'm going to get 3 color tiles that are blue. And I'm going to put them there to represent that. And just to stay consistent, I'll write the number 2. What I'm trying to find out, though, is if I put those red and blue notebooks into a stack in my cart, my shopping cart, how many notebooks would this be? I want to know my whole. So what is it when I put those 2 parts together? Well, I can actually do that. I can physically move my 2 red and my 3 blue. And when I put them together, how many is that? Well, there's 2, 3, 4, 5. So 2 and 3 is the same as 5. And I can record that in my sentence stem. I'm going to use my one that's for composing. 2 and 3 is the same as 5. Okay, I see it right there. Here's a part. Here's a part. When I put those parts together, I get my whole, which is what gives me 5. Our students can also do this at the representational level, which they would just draw this. So they could put the numbers if they wanted. They didn't have to. They could just draw. We want our drawings to be very simple, so I'm just going to use dots. There's my 2 for my red, and my blue is 3. And if I want to put those 2 parts together, I'm going to go ahead. Here's my 2 that are red. And then I also need to put my 3 that are blue. I could use different colors for this as well. But now let me find out how many is that. There were 2 there. I know that. 2, and I'm going to count on 2, 3, 4, 5. So 2 and 3 is the same as 5. So we can start off by doing this at the concrete level, and then we'll move our students to the representational level, which is where they'll be doing drawings. One way in which we can work with our students with IOA 5A, compose and decompose numbers to 10 using objects and drawings, is through the use of dot cards at the representational level. Now, this will eventually be an activating strategy for our students to work on 5D, fluency with addition and subtraction within 5, but we can do this with AKS 5A, or excuse me, IOA 5A as well, with our numbers up to 10. So with a dot card, you show it to them and you ask them, how many dots do you see and how do you see them? We actually have the very last lesson of the unit with these dot cards so that we can teach it to students before, like how to work with the dot cards before we move it into activating strategies. So with this, I'm going to show them an image and ask, how many dots do you see and how do you see them? And then we're going to record some of the ways that we can see these. So if I look at these dots, we might have a student say, or I can model my thinking, well, I see a group of 4 and a group of 2. So I have this part with 4, this part with 2, and if I put those 2 parts together, that gives me 4, 5, 6. So 4 and 2 is the same as 6. Okay, we might have students see it a different way. So we may have some students that see it, and I'm just going to put this one up, and here is another one. So I want to have multiple of this image so that we can see all the different ways. I might have some students say, ooh, well, I see 2 on the top and 4 on the bottom. And when I put the part 2 and 4 together, 2, 3, 4, 5, 6. So 2 and 4 makes 6. So just like 4 and 2 is the same as 6, 2 and 4 also make 6. Or we may have students that see it different ways. We might actually have a student that sees it as, maybe they know like that's 4 and then 1 more. So they're looking at that as 1 part. So there's 5 and then 1 more. So 5 and 1 make 6. So we've got 4 and 2 is the same as 6. 2 and 4 is the same as 6. And here's one that's 5 and 1. We don't have to limit our number of parts to only 2 parts. We might have a student that sees it this way. Here's 2, here's 2, and here's 2. So now we have 3 parts. This part has 2, this part has 2, and this part has 2. But when I put them all together, that makes 6. 2 and 2 is 4, and 5, 6. So they might see that 4 is 2 groups of 2, or they might see, well, there's 2, and then I can count on 3, 4, and then I can count on 5, 6. So that would be a 2, 2, and a 2 that makes 6. So we're going to introduce these dot cards in a lesson so we have time to explain and to model for students how we can see different parts out of the whole and then compose them to figure out how many are in the whole. And then this will end up moving into our activating strategy with dot cards, specifically with numbers within 5 as a way for us to build that fluency with our addition facts within 5 of those, just all the different combinations for up to 5. So this is another way that we can work with our students on IOA 5A as we're composing parts to put them together to find out how many dots are in the whole.
In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview.